Hi, everybody. My name is Sheri Byrne-Haber, and I'm here today to talk about an automated accessibility machine learning project that I've been working on for the past year at VMware. I started the accessibility program at VMware just about 2 years ago, and we've grown from one person to 16 over the last 2 years. One of the things that we're looking at, because we have 140 separate enterprise products, is how to do automation better, faster, and cheaper. Because as we're all aware, the ability to automate accessibility testing and in terms of commercial solutions that are available right now is quite limited. So first of all, just going to do a quick introduction to machine learning for those of you who aren't so familiar with it to make sure that we're all on the same page with the approach that VMware took. Then we're going to talk about the current state of accessibility testing. We'll talk a little bit about vAlly. Actually, we'll talk about a lot about vAlly, which is the project code name for the tool that we're getting ready to release into open source. It will actually come out under a different name because vAlly is not a VMware compliant name because it's got numbers in it. But when that new name is available, I'll make sure that everybody knows. And then finally, we'll talk about next steps. So first of all, the introduction. So machine learning was defined about 20 years ago by Tom Mitchell, and it's the study of algorithms that improve performance at something with experience. And experience implies repetition and time elapsed because you have to do things over and over, and you have to tell the algorithm this way was right and this way was wrong. So the flavors of machine learning that we looked at for implementing vAlly, one is natural language processing. So natural language processing is the manipulation of speech and text by software. So the natural language is the speech and the text, and the processing is done by the software. So for example, if you had a header and it was an H2 level and it was dog breeds, then for example, Dachshund should be an acceptable H3 because it's a type of dog breed. That would be considered a pass. Great Dane would also be considered an acceptable dog breed. So it's also a pass. Samoyed is a dog breed. That should be a pass. But alas, Petunia is not a dog breed. And so if you were doing something with automated heading checks, which isn't done right now in any accessibility automated software, you would want H3, this Petunia heading, to be identified as a failure. Image recognition is something else that we used for our vAlly project. Image recognition is the ability of software to identify objects, places, people, writing, and actions within images. So for example, we use tab presses with the keyboard quite frequently to navigate through activatable components on a web page. So you could do a tab press, you could take a screenshot, you could do another tab press and take another screenshot and compare the two images and know whether or not there's a difference between the two. But here's another more fun example. So this is the famous meme, am I a dachshund or am I a bagel? So we're going to look at the first column of the 4 vertical things on the left-hand side. Which one of these are dogs and which one of these are bagels? So the first one is a dog. Second one is a bagel, pumpernickel, my favorite. The third one is definitely a dog. And the fourth one, again, bagel. And so by using image recognition software, you should be able to recognize which ones of these boxes are dogs and which ones of these boxes are bagels. Pattern recognition is also somewhat related to image recognition. It's the automated recognition of patterns and regularities within data. So for example, for focus order, which is one of the most complicated things to test manually in accessibility review, you could use pattern recognition to recognize which patterns are good and which patterns are not good. So for example, in the English language, the patterns that usually work for the tab order is left to right and then top to down. But then for other languages, it might be completely different. For Hebrew and Arabic, it's going to be right to left, not left to right. And for some of the Asian languages, it's going to be only top down. So what are some patterns that we can see here? Well, for example, bagels don't have eyes, a tail, or noses. So if you could clearly identify that a picture had eyes or a tail or a nose, you knew it was a dog, regardless of what anything else the software told you. Also, dogs don't have sesame seeds. So if you can identify everything flavoring or sesame seeds or dough bubbles that are like in the lower left pumpernickel bagel, you automatically know that even if that bagel looks like a dog, it's not a dog because dogs never have those things. So supervised machine learning is when you take a whole bunch of unstructured data, okay, just data as far as the eye can see, and then a human manually sorts that data into data models. And you might have a good data model of what your good data looks like, and you might have a bad data model of what your bad data looks like. So here we'll see our human is saying all of the things that are dark blue are part of the good data model. And if you're red or if you're gray, you're part of the bad data model. So the human sits there and the human sorts through this stuff. We have found anecdotally that it takes about 750 of these types of comparisons. So 750 web pages worth of comparisons, not 750 little blocks of data. So the average web page might have, let's say, 50 activatable components on a complex page. So 75 times 50 is how many it takes before you start getting a high level of pattern recognition and good levels of repetition on your unknown data. So you now take those data models, you have your good data model, you have your bad data model, and then you test unknown data against it. So your unknown data checks against the good data model and it's a pass. And that can happen many times. And then what happens is if it fails the check, it will check against the bad data model, and then it will mark the other ones as failures. Now we're going to pivot to disability, and then we'll talk about the intersection between disability and machine learning. Disability is the largest minority group in the world. It impacts more than 1.3 billion people globally, and it comes in 5 different categories. So the 5 different categories are neurological and cognitive, mobility and dexterity, vision, hearing, and other. So other includes things like fibromyalgia and chronic pain, type 1 diabetes, lupus, other autoimmune conditions, cancer, for example. So 25% approximately of disabilities are visible. You really usually can't tell that somebody has cancer by looking at them. 75% of disabilities are invisible. Sorry, that's a typo. That should be invisible. So some examples of invisible disabilities are listed here. Cancer, as I mentioned, cystic fibrosis, diabetes. If you don't see my insulin pump, you can't tell that I'm a type 1 diabetic. But you do see my wheelchair. And so when you see somebody in a wheelchair, there's a presumption that there's something wrong with their mobility. So you can have more than one disability, and you can have more than one visible disability and more than one hidden disability in any combination. So now we're going to talk about the current state of automated accessibility testing. So accessibility means making sure that the software works for people with disabilities. That doesn't sound too hard, right? Until you realize that you never know what disability or what combination of disabilities that people might have. And so there's a standard called WCAG, Web Content Accessibility Guidelines. The version that we want everybody to test to is 2.1 AA. If you're testing to that level of accessibility, you're going to be good everywhere in the world that has an accessibility law, because that's the strictest accessibility law in the country. So how do you do that through automated testing? Well, right now, there's only one type of testing, which is code analysis. So you have a tool, it knows the good software patterns, it knows the bad software patterns, it looks for them, and it analyzes the code. However, that's framework dependent. because what looks good in Angular and the rules that you need to follow there look different in terms of how they're implemented than the code that you might be implementing for Swift or the code that you might be implementing for React. And finally, there's no open source for unlimited commercial use. There's nothing available. Also, you can't test using live data when you're doing code analysis because there is no data. You're only looking at the framework and the UI code. And so based on those constraints, only 30% of the Web Content Accessibility Guidelines for 2.1 AA can be executed automatically. So when I was starting my accessibility career at VMware, I found that we had under-tested our accessibility substantially. So this started as an idea when I realized that I had way more testing to do than I had time for. I was a testing team of one at that point. I had no budget, so it wasn't really possible for me to go out and write a 6-figure check to get a consulting company to give me results. And I had to figure out how I could make my testing more efficient and get more things done faster. So I entered it into a contest at VMware. It was called the CPBU Pitchathon. CPBU stands for Cloud Platform Business Unit. We call our divisions at VMware business units. And I competed against 20 other people in my division, and my idea was chosen as the winning idea. From there, I took my winning idea and I was asked to submit it to VMware's experimental development program, which is called X Labs. And we did what we call a proof of concept, which is, can we do something in 3 months that proves in a prototype whether or not this is a good idea? So when we were debugging the code and building the learning models, the supervised learning models for our machine learning, we started with one site that we knew was very, very accessible. Then we went to 30 sites, and then we went to 300 sites. So after each step, we were reviewing the results and feeding it back into the machine learning model saying, hey, you got these right, you got these wrong. And so the results improved over time. And ironically, we knew that it was a good idea long before the end of the proof of concept. What happened was we found a serious bug in the homepage of a computer company known for its public commitment to accessibility. And what had happened is at that company, certain things were supposed to be reviewed for accessibility before release. And in one case, the review wasn't done. And 2/3 of the keyboard focus indicators on that company's homepages were broken. And that got picked up because they were one of the 300 sites that we were testing for as we expanded our model. VMware partners started clamoring for it. As soon as we started talking to partners about it, they were like, when can we have this? It was something that is not like anything else that's out there on the market, and VMware decided to give it away. Under our EPIC 2 values, we want to give things to the community that are useful. We don't want to be in the test tools market. We don't want to force little companies to go out and spend money on accessibility testing or just do a poor job at it because they don't know how to do it. And finally, the project has been promoted to X Labs full track. So what that means is, since the 3-month proof of concept is finished and was successful, I now have a machine learning resource for an entire year. So we took the 5 ideas that we were originally planning and we've expanded them to 31, and we'll be doing 3 updates in 2021. Okay, so what are the 5 things that are in the proof of concept? Automatic detection of captions and subtitles in videos. So text recognition and a little bit of code analysis. Automatic detection of transcripts for podcasts. Now, these things might seem trivial, but when you think about it, it's not hard to tell whether or not a video is captioned or a podcast has a transcript. What is hard is finding the videos and finding the podcasts. If you have a site that's got 10,000 pages, you have to sit there and look at every single page and say, hey, do you have a video? Hey, do you have a podcast? By being able to automate that, we've really sped things up. The other reason why it was important to start with these was because my daughter's deaf, and she's always infuriated when captioning is not available. The third thing we implemented is the automatic detection of the presence of keyboard focus indicators. So that was the thing that I talked about that we found in the major vendor testing when we were debugging our code. And also, additionally, once the keyboard focus indicator is detected, automatic measurement of whether that focus indicator meets the thickness and contrast requirements. And we've actually set that standard for the upcoming WCAG WCAG update, which is 2.2. Finally, the last one, which was the hardest of the 5, why we left it to the end, automatic comparison of the heading text with the text after the heading. So remember that dog breeds example that I was talking about at the beginning, where, Great Dane, yes, Dachshund, yes, Samoyed, yes, Petunia, no. In order to do that now, you have to have a human sit there and read all the text. And again, 10,000 pages, that's a lot of text. So being able to get a good idea without too many false positives of what matches are good and what matches are not good really helps speed up that very intensive manual process. So for right now, if I wanted to test these 5 things on a specific page, it would probably take me on a complicated page, up to maybe 20 or even 25 minutes. With the software, we can test this now in 18 seconds. And the first 4 we can test literally with 100% reliability. We very rarely get a false positive or a false negative at this point. And the heading is a little bit lower quality, but it's because it's so much tougher of a problem to solve. We are at about 88% accuracy right now. And as we expand the data models, we hope that that number will improve. Okay, so what are those are the 5 that we did. What are the ones that we're adding? So we're adding for links to consider ARIA overrides. Right now, all the software tools that are out there will tell you if you have a link that says click here, but it won't tell you if you have a vague piece of link text, but it's okay because it came with an ARIA override. A couple of the things on here, and I'm not going to read all of these, but name role value. So that means if you have something that changes state, for example, a checkbox checking something, a tab switching the text underneath, a radio button being selected. All of those things, when the state change takes place, the state change itself is supposed to be passed on to the screen reader user, somebody who's blind who couldn't see the state change take place visually. That's not tested right now in any other tools available that I'm aware of. And so that was something that we had very high on our list. Timeouts are really a pain in the butt to test for in the real world, because you have to sit there and wait for it to time out and then see if it did the right thing. And so that is quite a headache to test manually. And so we are automating both form and session timeouts. Looking for autocomplete, looking for responsive behavior. Responsive behavior implies that magnification should work. Magnification is a pretty significant need of many, many users. About 1.5% of the population uses magnification. So status messaging is a new requirement that came out in WCAG 2.1 about 2 years ago. And so you need to have a live region if there is an action that triggers a status message. And so that's something that's not being well covered in current automated testings. The keyboard focus approach needs to also be applied to image buttons and not just text. Looking for automatically moving carousels, taking inventories of things and comparing them from page to page for consistency purpose. Looking for the correct use of keyboard shortcut guidelines. Looking for good CAPTCHAs. At VMware, the standard is that everybody is supposed to use the Google I am not a robot CAPTCHA v3. And so that's the standard that we're putting in to vAlly. But this could be adapted to whatever is considered a legit CAPTCHA for your organization. A legit CAPTCHA has to have, at a minimum, both an audio component and a comparative visual component, so that somebody who's deaf can do the visual test, somebody who can't see can do the audio test. Focus order, as I mentioned before, that's going to be pattern recognition. That's going to be tied to what language is in use. And then finally, described audio / audio description depends. It's the same thing. It's just different people call it different things. So that's just like the captioning, except you're looking for special soundtracks for people who are blind. So those are the 21 things that we're adding that cover 26 of the W3C WCAG 2.1 AA guidelines. And we'll also look at 2.2 when that gets final and see which ones of those can be automated as well. So how did we test VLI? We did supervised learning at every level. So we started with one, which was uk.gov. That is the most accessible site out there. Then we took a random sampling of 31 sites from 8 different industries, tested against that, kept on building our data set. If things were, if VLI gave us the wrong answer, we fed the correct answer back into the data model. Then we took the top 300 safe for work sites. I'm ashamed to admit I just grabbed the top 500 originally from Alexa, not thinking. And it turned out that a lot of the top 500 sites in the world aren't exactly safe for work. So we reduced it to the top 300 safe for work sites. And then we branched into building custom data models based on the partners. So the first 3 feed into a generic data model. And then we started branching into building a specific data model for VMware based on our 140 products. So what we'll be releasing is the data model after the top 300 safe for work sites, the generic data model. Then people can customize on top of that by feeding in their own supervised learning for their own particular products. So next steps. First of all, I'm going to play a short demo of how this works. And then I'm going to talk about our upcoming release date. And if you want to either use VLI or be a contributor to VLI, how to go about doing that. Hi, I'm Sheri Byrne-Haber, an accessibility architect and the founding manager of the VMware Accessibility Program. Accessibility testing today largely requires manual testing. The split is about 30% automated, 70% manual. That's because automated accessibility tests only inspect code. They don't use machine learning where images, text, and patterns could be recognized and processed to see if the behavior was correct and not just whether the code was correct. A year ago, I had an idea. What if we took some of the tests that were manual and automated them using machine learning techniques? This idea won the first CPBU Pitchathon contest. From there, I submitted the idea to X Labs, where it was approved as an X Labs Lite project. We took 5 elements of accessibility, which were very manual and time-intensive, could only be tested using humans, and automated them using a variety of machine learning techniques using only open source tools. Of the 5 tests, 4 of them were automated with 100% reliability in the results, and the 5th was automated with 88% reliability. Since the 5th is using supervised learning, we should be able to generate new results and feedback false positive corrections and improve that result. Because of this great start, we were approved for an X Labs full track extension, and we've identified 26 other elements of the Web Content Accessibility Guidelines that are currently only being able to be tested with people. We'll be automating them over the next year. All of this was done with entirely open source tools and libraries such as InstaML, VBERT, and Beautiful Soup. We're going to be releasing this tool into the open source by the end of the year. It doesn't have a name yet, but when it does, I'll let everybody know. By the end of 2021, we estimate that the 30-70 split between automated and manual accessibility testing will be close to a much more manageable 50-50. I'm going to play a demo of the first 2 of the 5 elements we automated, which were the keyboard focus indicator presence and the contrast of the keyboard focus indicator.
Hi everyone, I'm Amit, a machine learning intern working on automated accessibility testing. Our first task is to automate the detection of keyword focus indicator. To perform this task, we take CSS for each and every focus component before and after the tab press and notice if there is any change in the background, foreground, border of the component, and then calculate the luminosity ratio. Let's have a quick demo. We just need to provide the URL. This graphical interface is just for the demo purpose. In the production, it will run in the headless mode. Now we will be checking color contrast of all the focus elements and report back all the failed elements based on the WCAG guidelines. So here we have found 92 elements in total and only one element is getting failed because of low contrast on focus. This is the XPath of that element. On top of that, we have also provided a screenshot where all the failed elements are highlighted with red color. And one thing I wanted to bring to your notice that our program took around 18 seconds, whereas it takes at least 25 minutes if we do it manually.
Okay, so how do you guys get access to VLI? Oh, it's going to be released on Git. There will be a package that you can download and install. You can either use the default model, which we will provide you, or you can build your own model. You can integrate VLI API calls into your favorite test harness or check-in process. So one of the things that we're doing at VMware is we are taking we're taking result sets from accessibility tests, labeling them as the gold standard. And then anytime a new container check-in takes place in Docker, it will run the tests behind the scenes. And if the check-in, if the code being checked in causes any new tests to fail, that check-in will actually be rejected. So it's harder to stay accessible sometimes than it is to get accessible. And so by shifting left and pushing earlier into the development process where the accessibility sometimes gets broken, you're more likely to end up with an accessible end release that will make your users happy. Then what you want to do is you want to review results and feedback corrections into your model. Now that's optional. It depends how serious you are about this and how much time you want to invest. Okay, so if you're interested in contributing to VLI, we need help with the following. We're looking for early testers for work that we're doing in 2021. We're looking for people who can help us translate the documentation. We're looking for larger, more evolved generic data models for other VLI users to be able to work from. We will be setting up a Slack channel so that people who are maybe not as highly tech skilled can ask basic questions. And you can also participate in coding one of the 26 planned editions in 2021. This is how you can get a hold of me. You can reach me either on Medium or on LinkedIn. And thank you for paying attention to my talk today and look forward to hearing back your feedback on the VLI machine learning tool.